Lesson 106, solving literal equations, transforming formulas, and more on roots. So a literal equation just contains variables. As a reminder, variables are letters. So they contain variables instead of numbers. So if you have, here's an example of solving a literal equation. You have to be told what variable you're solving for because all the other parts of the equation are variables. So if we're told in this example, solve for x, x minus a equals b. We use all of the tools that we've used before to solve an equation. So even though a is a variable, we still want to add it to both sides so the x is by itself. So for instance, if you guys remember, if this were a number, we'd have to add to the other side. So we're going to add a to both sides. Now b and a are not like terms. So x equals b plus a. So we can't combine them in any way except for to add them with the plus sign. So if you remember, we want to undo subtraction. Put undo in quotes because we're just kind of by adding. So if you notice, a is subtracted, so we undo it by adding to each side. And each side means each side of the equal sign. We only add it once to both sides. So changing a formula means solving it for different variables. So here's another one. If we say solve for x, x times a equals b. Now if something is multiplied, we want to undo multiplication by dividing. So when it's multiplied, you put a line under both sides of the equal sign and we divide by a. This gives us 1x. So x equals b divided by a. So to undo multiplication, I'm running out of room. We want to divide both sides. Here's another example. Solve for pi. Now in this equation, they're going to have pi. And I told you at the beginning that literal equations only contain variables, and pi is a number. So either I lied or I felt like that letter pi counts as a letter. It's not really a variable because pi is a number. So a equals pi r squared. You guys have seen this before? This is the formula for area of what shape? Say it out loud. Circle. Okay. So we're going to solve for pi. Now pi is on the right side of the equation, and that's okay. It's being multiplied by r squared. So to undo multiplication, we're going to divide by what's being multiplied by what we're trying to solve for. So this is pi equals area divided by r squared. Now I switched sides of the equal sign. Since they're equal, I can do that. That didn't throw anybody off, did it? That I moved my pi over here and that over there. Okay. Here's another example. Solve for s. P equals 4s. Any idea what this is a perimeter of? If you just do 4 times the side length? Luke?
Square.
It's a square. Excellent. We're solving for s. So first we have to find s in our equation. It's over here, and it's multiplied by a 4. So we need to divide by 4, and s equals perimeter divided by 4. Oh, no. Okay. Roots. We're going to be talking about roots. This is like the square root of a number. When you see the square root of 36, you automatically know that is what number? 6. If you saw that x squared equals 36, now we have more than one answer. So when you see the square root of 36, it's always just 6. If you see that there's a number squared and it equals 36, you can have 2 answers. It can be if you take the square root of both sides. So to undo squaring, we take the square root, but we have to take, I forgot to put right here, the positive and negative. That's an equal sign. Equals, when you take the square root, it's the positive and negative square root of 36. So the square root of x squared is just x equals the positive and negative square root of 36, we said was 6. So plus or minus 6, that just means 6 or negative 6. And I always just say plus or minus 6 instead of saying 6 or negative 6. You can use the plus and minus sign. Now when we have the positive square root, let's see, I'm going to write my sentence right here. The positive square root of a number is sometimes called the principal square root. So anytime you see the square root sign with a number inside of it, the answer will always be the principal square root, or the positive. The only time you're going to see that it's plus or minus is if you have to take the square root in order to solve something that's been squared. So we're going to write that in a sentence. I'm turning the page. Y'all caught up? I'll count down. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. So this symbol is called the radical symbol. So this radical symbol usually means they want the principal square root as the answer. In other words, the positive square root. So you're going to have questions, and they're going to prompt you with these questions. So it actually makes it a little bit easier. You'll have questions. This is an example like this. What are the 2 square roots of 100? The key word is 2. You're going to have 2 answers. So we know the square root, the principal square root is 10, which means the other one is just negative 10. And that's because negative 10 times negative 10 will give you 100. So the 2 square roots is 10 to negative 10. Now when we have the square root of something, doesn't matter what it is, we'll do some examples, 25. You look for pairs. In other words, 25 is 5 times 5, so I can rewrite this as 5 times 5. If you notice, they're a pair. So you take one of them out. So the answer will be 5. So I like to circle the matches, the ones that match, and then you take one of each match out. So if we had something like this, 100 x to the 4th y squared, and we talked about this I don't remember when it was, if it was yesterday or not. We have, if you had to do 100, that's 10 times 10, and 10 is 2 times 5, 2 times 5. So if I put all of my prime numbers under here, and I'll put the 2's together, the 5's together, x to the 4th is 4 x's, y squared is 2 y's. Then we circle the matches. So we have 2 2's, 2 5's, 2 x's, another 2 x's, and another 2 y's. We take one of each match. Outside the square root is no longer there. So we have 2 times 5 times x times y. So it's 10 x squared y will be the square root of this. And remember we talked about if the exponent is even, you just take half the exponent. So you actually don't have to write it out in circle pairs, but a lot of times it helps with trying to find the square root. Now we're going to introduce cube roots. I don't know if you guys ever heard of a cubed root. Maybe in 5th grade? I don't know. Or 6th grade. We are going to start with one that we can find. So the cube root of 27. It looks like this. So we have the radical symbol, and we put a little 3 right there. That's called the index. That means we want to find one number that multiplies by itself 3 times and gives us 27. So we can look for triples. You know, in the square root we looked for doubles. In the cubed root we can look for triples. So I like to do my factor tree. 27 is 9 times 3. 9 is 3 times 3. So the cubed root, 27, is the same thing as a cubed root of 3 times 3 times 3. We circle triples, because that's this number 3 right here. It tells us circle 3 at a time. And then we take 1 out. So the number's 3, because 3 cubed is 27. So we take one of those 3's out. I'm going to do one more example. The cubed root of 1,000. So we're trying to find a number that when you multiply it by itself, you get, you have to multiply it 3 times by itself. Well, 10, I shouldn't have circled those because they're not really, each 10 has a 2 and a 5. So we have 3 2's, 3 5's, circle the triples. We have 1 2 comes out and 1 5 comes out. So this is going to be 10. The cubed root, make sure you put a little 3 right there. So the cubed root of 1,000 is 10. And you can always check your answer and say, okay, well 10 times 10 is 100 times 10 is 1,000, so it's correct. So you could do it 3 times and get 1,000. That's the end of the lesson. We're going to do some practice.